In this module, we will cover the prototype pattern. Its intent is to specify the kinds of objects to create using a prototypical instance and create new objects by copying this prototype. I'm Kevin and I'll guide you through it. We'll start by describing the pattern and by looking into the pattern structure. As a real-life example, we will use the creation of an employee and a manager, both deriving from person via a clone method. After that, we'll dive a bit deeper into shallow versus deep copies, which we'll both implement. We'll cover the iClonable interface as well, and after that, we will learn about use cases for this pattern, pattern consequences, and related patterns. Let's dive in. The prototype pattern is one of 23 Gang of 4 design patterns. It belongs to the creational patterns group, which means it's a pattern that deals with object creation. This is the last one of those that we'll cover. The intent of the pattern is to specify the kinds of objects to create using a prototypical instance and create new objects by copying this prototype. In other words, it lets us copy existing objects without making the client code dependent on their concrete classes. It's a pretty easy pattern, but as with most of these pattern definitions, they're easier to understand with an example. So let's dive a bit deeper into that definition. Imagine we have a system in which we work with people. We can simply create new people by newing up instances of a person class, or more realistically, assuming that person is an abstract class, an employee or manager class that derives from person. Now imagine the use case where most property or field values of an existing object are required in a new object. Or maybe you even need all property values of the new object to match the existing object. In that case, we can simply copy them over. But that requires the client to have intrinsic knowledge of the concrete classes we're working with, employee and manager. It also needs to know how to create them. We can go about this in another way as well. We could create a method on our employee and manager classes, clone, that will return a copy of itself. Moreover, as we know both employee and manager derive from person, we can define this method on the person class and override it in the subclasses. The client application only needs to know about the person class's clone method to be able to clone subclasses like employee and manager. What you see here is the prototype pattern at work. In essence, it describes a way to create a new object by cloning an existing one. Let's map this example to the pattern structure. The prototype pattern obviously contains a prototype class. That prototype declares an interface for cloning itself. It maps to our person class. A way to implement this would be as an abstract base class with an abstract clone method on it, but as is often the case, an interface is possible as well. And now we've got the concrete prototype. These are implementations of the prototype that implement the actual clone operation, which returns a copy of itself. This thus maps to our manager and employee classes. And lastly, we have the client. This one creates a new object by asking a prototype to clone itself. So the only thing we still need to change to our prototype pattern structure is that the client doesn't execute clone on person, but it does so on prototype. And that's it. Now we can go ahead and implement this pattern using our real-life example. So, time to implement our pattern. Let's start with the prototype itself first. We're going to use an abstract base class for that, defining a name property and a clone method which returns a person object. That's the prototype, a clone of itself. And now we need to implement this. Let's start with a manager class deriving from person. That means we need to implement the abstract base class, so let's do that. And we see that we need to provide a name. What we can do for that is add a constructor that accepts that name, thus conveying that we expect this object, the manager, to be constructed with a name. And there we go. You can now simply change this to getters and setters via auto property syntax. In the constructor, we set the property name to the pass-through name. And then we also need to implement the clone method. We could implement this by newing up a person and manually copying over all the fields, but there's an easier built-in way to do this, by calling into member-wise clone. This is a method that's defined on object, so every instance you use in C# has access to this. It creates a shallow copy of the existing object. We'll get to what shallow copy means after the demo. For now, this is sufficient for our manager class. Then let's add another concrete prototype, employee. It's more or less the same as the manager class, with one difference. An employee has an additional property, its manager. So we construct this one by accepting a name and a manager object. Let's test this. Let's new up a manager first. For that, we need to import the prototype namespace. We'll pass through a name, Cindy. And then we'll try to clone this manager. For that, we can call clone on the manager object. Note that we do need to cast this back to a manager if we want to use it as a manager, because the clone method returns a person object, the abstract base class. And then we do the same for employee. The difference here is that we pass through the manager we just created. Let's give that a try. And that seems to work just fine. The manager clone's name was written out, and that is Cindy, which means cloning the manager seems to work. Employee was cloned, which worked out just fine, and the manager is Cindy. Makes sense because that's what we passed through. If we now pass through the manager clone instead, we should see the exact same result. Let's give that a try. And that is indeed the case. So this seems to work well. But let me make one small change. Right before the read key statement, let's change the manager name and write out the employee info again. Let's give this a try. And that's a bit odd. The manager name on employee clone was changed, even though the clone was created before we changed the name. That may be what you want, but often it's not. You might expect to get an actual copy of the manager object as well when you clone the employee object. This is a limitation of member-wise clone. That statement always creates shallow copies. Getting an actual copy of the manager object as well would mean we need support for deep copies or clones. Let's compare these. A shallow copy is a copy of primitive type values. So strings, integers, and so on will be copied. These are independent of the original object. But complex types that might be properties of the object you're cloning will be shared across the different clones. Because of that, changing a value from that complex object, for example, the manager's name, results in changes on both the original object and the clone. A deep copy, on the other hand, also results in copies of the complex types. In that case, we can modify the complex object properties of the original object without it affecting those of the cloned object, and vice versa. Let's see how we can support this. In this demo, we'll add support for deep copies or clones. Let's start by adding a boolean, deep clone, as parameter to the clone method signature. We do that in the person abstract base class, which means we also need to do this in the manager class and the employee class. Personally, I like passing through a default value for this, false, so clients don't have the obligation to be explicit about this. That's it for the manager, and we do the same for the employee. Alright, all that's left is effectively creating such a deep clone. We could manually traverse the object tree, creating shallow copies of each complex type and assigning it as a property value. But a more common approach is making a binary copy using a binary formatter. The code for that would look like something you see on screen now. However, since that formatter was introduced in .NET, deserialization vulnerabilities were discovered. As a result, this does not follow modern best practices, and the deserialize method can be used as a vector for attackers to perform denial of service attacks against consuming apps. This is not something that can be solved with this binary formatter. So what Microsoft currently recommends is to simply no longer use the binary formatter anymore. If you want to read more about that, you can do that via the link on screen. So what do we do now? Well, a common approach is to use a JSON serializer instead. System.text.json is built in, but it currently doesn't support parameterless constructor classes, and that happens to be what we have here. But luckily, JSON.NET does. So let's give that a try. First, let's open the NuGet dialog. And let's look for JSON.NET. Newtonsoft.json is how you can find it. Let's install it. And there we go. We need to import the Newtonsoft.json namespace, and from that moment on, we can call serialize object on our current object, and after that, deserialize that object. So first we serialize to a string, and then we deserialize that string back to an object we can return. The warning you see here is that this may return a null value, but that's okay for us. And we do the same in the manager class. But this time we deserialize to a manager. Let's test this. To do that, we change our clone call, this time requesting a deep clone. We do that when cloning the employee. And let's give that a try. And there we go. This time we do get back the expected result. We change the manager name after having cloned the employee, yet cloning the employee also cloned the manager object, which means that we see the manager name of the clone and not the name change we passed through. This is effectively a deep clone or copy. Let's have a look at something else next, the iClonable interface.